This video is on solving systems by substitution method. So here are the 4 steps we're going to follow when solving any system by substitution. So step 1 is to isolate the variable. So let's say we had the following system. Step 1 says to isolate a variable. So this is already isolated for us. The y is already by itself isolated. So step 1, I can skip. So step 2, you're going to take this and substitute this value into the other equation. So step 2, I'm going to take this equation. It is very helpful if you highlight or somehow circle so that you know that this is the equation we're plugging into this equation. So I'm going to take x plus y equals 4, and I am going to take out the y. I'm going to take that out, and I'm going to plug in 3x for y there. Everything else gets brought down. Okay, now I'm ready for step 3. So step 3 is to solve to find the first variable. So I'm going to solve this like in chapter 2. I'm going to solve an equation. So I'm going to combine the like terms. X, 1x plus 3x is 4x. And then divide by 4. We get that x equals 1. So solve to find the first variable. We found the first variable. Then the very last step, step 4, step 4 says substitute the answer you just obtained, so 1, back into another equation. So I'm going to go back to the start. So this was the original problem right here. And I'm going to take 1 and pick 1 and plug in 1 for x. So if I plug in, it doesn't matter which one, so I'm going to pick this one. And I'm going to plug that in. So you're going to make a total of 2 substitutions when you use this method. So instead of x, we're going to plug in right here 1 for x. And we get y equals 3. So our solution is 1, 3. Okay, so it is very important because there's lots of room for making math mistakes. There's a lot of math going on here. So to check it, you need to take the original problem, x plus y equals 4, and substitute what you got in for x and y. So I got 1 for x and 3 for y. So 1 plus 3 is 4. It worked. But it has to work for both equations. So I need to take the other equation, y equals 3x, and now plug in y was 3 and x was 1. So 3 times 1 is 3, and it makes both sides equal. So we're trying to figure out what does x and y have to be to get 4, and what does x and y have to be to also make this equivalent. Both equations equivalent. If this solution, so this is my answer, if it only worked in one, then I would know I need to go back there if something's wrong. Okay, so let's take a look at another example here. Okay, so for this example here, y is already by itself. So for this problem here, we're going to skip step 1. So we're going to take step 1, we skip. Step 2, we're going to take this and put it in for y right here. So then it's going to be 6x minus 7y, this is y, but I'm going to put it in parentheses here because it's multiply, and I put parentheses, that means multiply there, equals 27. So I literally just took the x minus 4 and replaced the first equation with that. Okay, so now step 3, we need to solve this. So we're going to distribute first, so negative 7 times 1x is negative 7x. Negative 7 times negative 4 is positive 28. Bring down the 6x. Okay, now we're going to combine the like terms. So all that I'm doing right now from this point forward is all from chapter 2, solving equations. So 6x minus 7x is 1x. And then we're going to subtract 28. And we get that x equals negative 1. So we found our first value. Okay, so now step 4. We're going to go back and pick one of these. It does not matter which one. I'm going to go with the bottom one. And now I am going to take out the x and put in for the x right there what we obtained from step 3. So y equals negative 1 minus 4. We get negative 5. So our solution is negative 1, negative 5. And remember, you can plug it back in to make sure it is correct. Okay, let's go ahead and take a look here. Okay, same thing here. We don't need step 1. Step 1 we can skip because the y is already by itself. And one of the variables is by itself. So step 2, I'm going to take the original equation and I'm going to plug in for y. I'm going to plug this in right there for y. So I don't need parentheses because there's nothing to multiply in front of it. So I'm going to put 2x plus 8 in for the y right there. Okay, now step 3. Step 3 we're going to simplify. So I'm going to put the negative 2x with the positive 2x, and that makes 0. They cancel out. So we're left with an 8 here equals an 8 here. There's no x, so x does not equal just one number. When this is true, that means your answer is infinitely many solutions. That means there's a lot of numbers that can go back in to both of these and make both sides equal one another. Okay, now let's take a look at this example here. So same thing, all 4 of these problems, one of the variables was already ready to go for us. So step 1, we can skip. The next example we do, you won't be able to skip it. So for right now, we're going to skip step 1, and we're going to take the other equation. So x plus 2y equals 13. And instead of x, we're going to plug in 9 minus 2y. So instead of x, 9 minus 2y. Again, I don't need parentheses because there's nothing in front of it. So step 3, we're going to solve this. So we're going to combine the like terms and they cancel out like the other problem. This time though we have a 9 equals a 13. That is not true. So that means our solution will be no solution. So if you remember from the section before this in class, we talked that graphically, no solution, if you were to solve this by graphing, they would be parallel lines and they won't ever intersect. That's why it's no solution. So if you were to graph these equations, they will not ever intersect. Okay, let's do one last example here. Okay, so notice step 1, we can't skip. We're going to have to do step 1. So the best thing to do is we need to either get this x by itself, this y by itself, this x, or this y. We have 4 options. The best one to pick is the one that has a 1 in front of for the coefficient, a coefficient of 1. So that's how I selected this one. So step 1, I need to get x by itself. I want to get this x by itself. So we're going to add 2y. And now the x is by itself. It doesn't matter which one of these goes first. I'm going to put the 2y first because I have the habit of putting the variable first. Okay, so that was step 1. So now I have one of the variables by itself. So now step 2. I take the other equation, 5x minus 4y equals 9, and instead of x, I know what x is right here. I'm going to plug that right on in. So I have 5, and instead of x, and I need parentheses because there's a number to multiply to distribute, I'm going to put 2y minus 3. So instead of that x, I put what x equaled right there. So now step 3 is to solve that. Get what y is. So 5 times 2y is 10y. 5 times negative 3 is negative 15. Then bring down the negative 4y and everything else. Then we're going to combine like terms. So 10y and negative 4y, they're different, so we subtract and get 6y. And I'm trying to get y by itself. That's what I want to get by itself. So I'm going to add 15. And then divide by 6. And now we have 4 for y. Okay, now we're on to the very last step, step 4. Step 4 means go back, pick one of these, it doesn't matter which one. So I'm going to go with, I'll go with the top one. Doesn't matter which one. And we know what y is right here. Y is 4. So instead of y, I'm going to put in 4. So negative 4 times 4 is negative 16. And then add 16. And divide by 5. We have x equals 5. So our solution to this system is 5, 4. So again, if you want to check this, you would plug in both of these numbers back in for both equations and make sure it works for both equations.